Hello, students, and happy March 26th. Let's get started with our lesson. We'll start with our do now, and we've got a great prompt today. We're going to talk for a minute about hoodies. So our objective today will be to review those exponent rules that we've been working on, just a quick review today. So our essential questions ask, what are the exponent rules we've learned, and how do the exponent rules work together? Our assignment will be to complete the do now, complete the 2 work pages. There's a practice page and an error analysis. You know I love the error analysis. We've got an exit ticket, and remember, show your work to me. That's how you get such great credit. So many of you are doing a great job with that. If you don't finish, you can do so for homework, but I think everybody's going to finish today. Remember, practice makes not only perfect, but proficient. So we do have an exit ticket. It's got quite a few things to it, so we're going to go through each one of these as we get to the end of our lesson. So let's move on to our do now prompt. Today is National Hat Day. So here's the question. Why do people wear hoodies? I wonder, people didn't wear hoodies so much when I was your age, but boy, now I see a lot of people wearing hoodies. Now I always think, well, gosh, are they hiding something or are they expressing themselves? Or maybe you're just cold, but I see hoodies when it's pretty warm out too. I'd love to hear your thoughts on hoodies. Why do we even say we shouldn't have them at school? What's the deal with hoodies and why are you wearing them? So please, I'd love to hear your thoughts. Please tell me your thoughts and write your thoughts right there. And we are ushering in April soon. So before we let March go, we're going to remember the March winds. Say March comes in like a lion and goes out like a lamb. So let's review those exponent rules while we have them in front of us. The product rule says if you're multiplying exponential terms, you add the exponents. Okay, maybe you should even write that down. So when you're multiplying, you add the exponents. You're multiplying the term, you add the exponents. Now, when you're raising a power to a power, like this example right here, you multiply the exponents. Now, also something that's been a little tricky that we've been working with, if you have 2 terms or more inside parentheses and you have an exponent just outside the parenthesis, it's almost like you're using a kind of distributive property on each one of those variables in the parenthesis, because you're going to apply that exponent to both, in this case, the x and the y. So that means you'll have xb, yb. That's what you watch out for when you have parentheses. Now, the quotient rule says that when you divide exponential terms, you subtract the exponents. So you're going to subtract the denominator, okay, from the numerator. So don't get that backwards. Now, if you have a negative exponent, then we need to put it in the denominator. If there's no other term that we can put in the numerator, we will put a 1. And once we put that negative exponent, that term, into the denominator, it can then become positive. Now, if we have a negative exponent in the denominator, then we can pull it out from under the denominator, and it then becomes positive. We haven't done many of those. We've mostly done like the ones on the left. And of course, if anything has an exponent of 0, whether it's a variable or a number, it is equal to 1. So those are the basic rules. So let's do some practice. So we're going to simplify each expression and write our answer using exponents. Well, we just said anything raised to the 0 power equals 1. So that's it. Now, number 2, we're multiplying 2 exponential terms. That means we add the exponents. So that would be 12 plus 35, and 12 plus 35 is 47. So it would be 10 to the 47th power, a very big number. Again, number 3, we're multiplying, so we're going to add those exponents. We need to add 4 plus -5 plus -9. Well, 4, we can think of it as 4 minus 5, which is -1, and then -1 minus 9, which is -10. So that's going to be our exponent. So it would be a to the -10th power. Number 4, we have a power rule. Power to a power. So that means we multiply the exponents. So that would be y to the 5 times 8, which would equal 5 times 8 is 40. And then number 5, again, we have power to a power, but I want to point out that this exponent of 8 outside parentheses, it applies to everything in the parentheses. So we have to multiply it by the 2 with regard to the x, but we also need to multiply it by the invisible 1 next to the 6. So 6, 1 times 8 is 8, and x, 2 times 8 is 16. Now, we could evaluate this 6 to the 8th power, but our instructions said to write our answer using exponents, so we're going to follow those directions. If we were to evaluate this 6 to the 8th power, it would be a very large number. It would be more than 1.5 million. Remember, exponents make numbers get very large quickly, and they can also make numbers get very small quickly. So now here we're dividing, and when we divide, we want to use the quotient rule, which means we will subtract the exponents. So it will be 18 to the numerator exponent 4 minus the denominator exponent 15, and that's going to give us a negative number because 4 minus 15 is -11. Well, we're not happy with, we can even write that, not happy with a negative exponent in our answer. So we will revise this answer so that we have 18 with a positive exponent of 11 in a denominator with a numerator of 1. Now, let's do some error analysis. My favorite. I love it. I love to look for the mistakes because it helps us get really sharp with our work. So let's see what this person did. We've got x to the 2nd power times x to the 9th power, and we're multiplying. When we multiply, we add exponents. Well, what did this person do? They multiplied the exponents. That's what you do with the power rule. So what they should have done, they should have added the exponents. So we're going to go ahead and solve that correctly. So x to the 2nd power times x to the 9th power is x to the 2 plus 9 11th power. And that's the correct way to do that problem. So let's look at this next one. We have 3 to the 4th being divided by 3 to the 7th, and they say the answer is 3 to the 3rd. Well, we know that when you divide, you subtract the exponents, but they subtracted the numerator from the denominator. That's not correct. You should subtract the denominator from the numerator. So let's write all that out. So you should subtract the denominator exponent from the numerator exponent. So let's solve this correctly. And we'll show all our work. We have 3 to the 4th being divided by 3 to the 7th. So that will equal 3 to the 4 minus 7. And 4 minus 7 is negative 3. So the answer would be 3 to the negative 3rd power. We don't like those negative exponents, so we're going to put it in the denominator under 1 with a positive exponent of 3. And here we are. We've shown every step as we did this. I know you're doing that as well. All right, so this next one, we've got, okay, a lot going on. Let's just look at this part, okay, in the green rectangle. We have m to the 2nd power also being raised to the 5th power, so that's the power rule. Then we have m to the 3rd power, n to the 5th power being raised to the 4th power, so that's the power rule. That means we need to multiply exponents. So m 2 times 5 is 10, and that seems okay. Then we have m 3 times 4, so we have to do 3 times 4, which is 12, that's okay. And then 5 times 4, which is 20, and that's okay. So this line here seems to be okay. Let's go to the next line. So now we have m to the 10th times m to the 12th, and they multiplied 10 times 12. No, and let's write that in a better place. So, no, they should have added the exponents. So let's do that correctly. I'll start right at the very beginning. M to the 2nd raised to the 5th power times m to the 3rd, n to the 5th, and all of that raised to the 4th power. So starting on the left side, and that's multiplied. I don't have to put the dot in the middle, or I could. So we have m, we'll use the power rule. 2 times 5 is 10 times m, again the power rule. 3 times 4 is 12, and n, 5 times 4 is 20. So far, so good. Now we need to multiply the m's together, and that's where the mistake was. So it should be 10 plus 12, which is 22, and then our n, 20. And that's a final answer. And then finally, we have a more complicated division problem. Remember, we do the coefficients, the numbers, first before we do the variables. So 45 divided by 5 is 9. That's correct. A to the 5th divided by a to the 2nd, 5 minus 2 is 3. So this looks correct. And then b, 2 minus 6 is not 4. 2 minus 6 is negative 4, and that means that's going to have to go in the denominator. So this is the mistake, okay? So this should be a negative 4. So let's write that out. Should be B2 minus B6. It's going to be B2 minus, actually, I don't want to write it that way. I want to change it just a little bit the way I write it. So I'm going to write it B2 divided by B to the 6 is B2 minus 6, which equals B to the negative 4. So let's rewrite our answer. We'll start with the beginning. 45 A5 B2 divided by 5 A2 B6. And 45 divided by 5 is 9. A, 5 minus 2 is 3. That much was correct. And then B, 2 minus 6 is negative 4. Now we have to rewrite this with that, because we don't want a negative exponent. We'll put that in the denominator. So 9 A to the third is our numerator, and our denominator is B to the fourth. So very good. Let's go back to our exit ticket. Lots of things to answer in our exit ticket. Okay, to add or subtract exponents, combine like terms. And they have to be exactly the same. You can't change the exponents. To multiply exponential terms, add the exponents. To raise a power to a power, you multiply the exponents. To divide exponential terms, you subtract the exponents. If there is no exponent, the exponent is understood to be 1. Anything raised to the 0 power equals 1, and negative exponents must be moved to the denominator, where they will become positive. So I also have for you today a little extra something, since you finished a little early. I thought this was a great mindfulness exercise. It was about being encouraging. Okay, thinking of someone in your life who needs a pat on the back from you and how you can mindfully plan to do that. I also have, because it's National Hat Day, you can use your digital tools and you can color the hat any way that you like. I'm sure you'll do a better job than me. I'm not such a great artist, but I thought this was a fun hat. So, and you can even make it a new London hat. Go Tigers at the middle school. And then when you're done that, if you feel up to it, we've got a great fallen phrase, and it has something to do with hats. So thank you for your hard work and for paying attention. I'm so delighted with how hard you're working in math class, and I think you're just doing a great job. So remember, lots of practice, and you'll be great.